You guys get to be the class that gets recorded today, even though you're the third one that I've taught. First class, I didn't like the way it happened, the video happened. Last class, Stecky V came in for like 3 minutes and interrupted. It was all in the video and lost my train of thought. So we'll go with you guys now. Third time's the charm. Okay? All right. So today we're going to finish up curve fitting. We're going to do the back side of the note sheet. So that's where we're going to be on. We will get to the calculators at the end too. So we got that. Tuesday is going to be I think we have it planned out as a station rotation review where we'll set up 4 different areas in the room and then you'll kind of rotate around between them every few minutes and hit up all different kinds of problems. Okay? Wednesday then is your test. And so then the 4 worksheets, the 4 green worksheets that you have and the yellow formative, if you haven't fixed it yet, are all due on Wednesday. Okay? For the 85% club. If you're above an 85%, then for you, only the 2 reviews and the yellow formative are due. Okay? All right? And then Thursday and Friday of next week, we're going to graph sine, or we already graphed sine and cosine, so we're going to graph tangent, cosecant, cotangent, and secant on Thursday and Friday. Yes, sir. Which one? Over there. The note sheet. Okay. And then when we come back from break, then we'll talk inverse sines and get ready for your final. Okay? Because the final is less than a month away. Actually, what is it at? 1, 2, like 2.5 weeks away. Well, 3 weeks if you include Christmas break. Okay? All right? So here we go. So we're talking about at the end of a dock. Okay? We have the tides, and it ebbs and it flows, and the tides rise and they fall, and so it looks like this is a little extreme here now, but this is in Alaska. Okay? Okay? So at the end, throughout the day, the depth of the water at the end of the dock varies with the tides. I'm just reading the problem for you while you're watching my time-lapse photography here. The table shows the depths in meters at various times during the morning. High tide is at 4 a.m., low tide is at 10 a.m. So we would be coming in, getting closer to, so high tide is 10, so we would still be in the morning. Okay, so tide keeps rising and keeps rising. This is up in Alaska, so there's a reason why they have their docks are all attached to poles with rings around the pole. And for them, this is actually pretty normal. Their dock has to be that long because they have to get out there so that they can still get supplies in. Okay. This one. And this one. Okay. So what we need to do is we need to make ourselves a picture of this scenario. Okay? Okay? So we're going to graph our data points. Do we need anything with a negative x? What would that signify in this case? Backwards in time. I don't care about what the tide was yesterday. Okay? I care about what the tide's going to be going forward. So negative x's, quadrants 2 and 3, we don't need. Can I ever have a negative y if I'm dealing with the tides? Well, so in this scenario, depth of the water, can I ever have a negative depth of the water? No, because that means that the water would be above the, it would be all be weird. Okay? If you like the Matrix, in the Matrix, didn't the water go? So we're just looking at quadrant 1. So we need a quadrant 1 graph. Okay? looking at my data, if I want to numerically label my vertical axes, it looks like we go all the way up to 4.4. So I would say we would need to get to at least 5 on our vertical graph. Yes? Yeah. Horizontally, looks like they go by 2 hours. Now, instead of using 12 a.m., I'm going to go off of the 24-hour clock, and that's going to be 0. Okay? Because then I don't have 2 12s, because that would make it not be a function. Okay? Okay? So I'm going to go with 0, and then I'm going to go with 2 and 4, 6 and 8, 10 and 12. I'm going to put a 12p there for PM now, so that I don't have to go, 4 or, what does that mean, 16 hours kind of a deal. So that's what I'm going to go with. Okay? Okay? So at 0 time, that's at 2.55, so it would be somewhere right about there. At 2 a.m., we're at 3.8, so that'd be right about there. At 4 a.m., we're at 4.4, so that would be right about there. At 6 a.m., we're back down to 3.8, so that'd be right about there. At 8 a.m., we're at 2.55, right there. 10 a.m., we're at 1.8. 12 p.m., 2.27. Our next thing, so we've graphed our data points. Our next thing says that we need to make an equation. First thing that we have to do, so in order to make the equation, I should say, we need to make 5 decisions. Okay? The first one is the most important decision because it's going to determine what the rest of the decisions are. What do you think the first decision we have to make is? Sine or cosine? Which one do you want to go with? Sine, okay, because it looks kind of like a sine curve, right? Okay, right? So we're going to make a sine curve. Now, with that being said, where does the sine curve start? Low, middle, or high? Middle. So we need to find the middle. Okay? Luckily for us, it told us that high tide is at 4 a.m. So that means that this value right here is my high value, like we've been doing. Okay? It also told us that low tide is at 10 a.m. So this is my low value. How am I going to find the middle if I know the high value and I know the low value? I heard, what I thought you meant, not what I heard, but what I thought you meant is add them together and divide by 2. Yes, because you're 2 steps ahead of us already. Oh. Okay? Okay? So I'm going to go 4.4 plus 1.8, and I'm going to divide that by 2, and that's going to give me my middle, which is 3.1. Do you agree with that? Okay? Now, what were you doing? You were finding what were you finding?
I thought it was in the
No,
middle.
you weren't finding the middle. You were finding the amplitude. Because what's the amplitude then? Middle and the high or middle and the low, right? Okay, so what's the distance middle to high, middle to low? 1.3? Yep. Okay, so we got an A value. Now, we know what the middle is, correct? Okay, so I am going to I have this technology. You can just put a light line on it. Some of you have been doing that on that. I'm going to put a little bit of a line here at 3.1. Right? Okay? So that's 3.1. Because where does sine start again? Starts in the middle. So can I use 0 as my start? No, because these aren't matched up. Right? Can I use 2 as my start? No, because those aren't matched up. So I gotta find something else. Okay? So kind of looks like right in about here, right? Would be where it would fall, which would be roughly what time? 1 a.m., right? Okay? So let's use C is 1. Okay? Can't use 0 because it was below my middle. Can't use 2 because it was above my middle. 1 looks to be right in the middle, or right at. Okay? So if that's the case, that's my start, then I got to look and see where it comes back to that point. So it kind of goes up, then it pulls back down, then it comes back up, and it looks to be right about there where it comes back, right? Which would be what time? 1 p.m., right? So if my start is at 1 a.m. and my end is at 1 p.m., what's my period? My period is 12, okay? Which makes my B value be what? Somebody whispered it. Pi over 6, right? Yep, pi over 6. Do I now have enough information to make my equation? Yeah? All right, let's do it. What do we got? Y equals 1.3 sine, open, pi over 6, open, x minus 1, close, close, 3.1. A then B. Because we did it the first thing, right? I know, but we gotta find that middle first. Okay. Everybody with me on that? Okay. Now the next question says it wants us to find the depth using our function at 9 a.m. and 3 p.m. How are we going to do that? Okay, we'll use a calculator. Okay, what are we going to plug in for 9 a.m.? We're going to plug in 9 in for x. Okay, I would concur. But here's the hint before you do that. Okay? No matter what calculator you use, because we are dealing with a function that is dealing in pi, it's got to be in radians. So if you're using your own calculator, it's got to be in radians. If you're using our calculator, it's got to be in radians. Okay? So you got to know how to go back and forth between them. Okay? On the graphing calculators, it is actually super duper easy. So first off, what you should do is you should start yourself a brand new document. So that's a double tap the on and start a new document. Don't save whatever it is that you have. Okay? Then you're going to want to add a calculator. Okay? And then you can type it right in as is. 1.3. Sign on the graphers is located under the trig button, and then you want to pick sign. And then the fraction key is control divide. Gets you the fraction to make it look like that. Pi is under the pi key. Over 6 down here. Yeah. Right down here. Yep. Yep. Normally I would say it's the one with pi on it. Okay. Then we got to open up another set of parentheses, and now we want to go 9 minus 1 close close plus 3.1. Now, if we just hit enter on the calculator, it's going to give us some crazy exact sine or cosine answer. Okay? So to get around that, we're going to hit control, enter, and it gives us the decimal equivalent. Oh, it did? Okay. Sometimes the settings are where it gives you exact answers. Sometimes it gives you round. Or yeah, that one's just going to give it to you decimal. Because you didn't put pi over 6 in.
3 p.m. 6
Yep.
hour.
Yep.
17. Just like go back into
Okay, now, here's the nice thing about using the TIs. Okay, so what do we need to put for 3 p.m.? What are we going to input?
17.
We're going to input x equals 17. We putting in 17? 15. 15, right? We add 12? Yeah, 15. Okay? So on the TI Inspires, here's the nice part. Ready for it? We scroll up until the whatever it is highlighted. And then you hit enter. And there it is for you. And then you just have to change that 9 to a 15. Yes, it is. It is deleted. Oh, yeah, that's going to. That's weird.
4.22583.
What was going on there? I have no idea why it did what it did. Yep. Now, oops, wrong way. Way down here, farther. Oops. Come on. There we go. Way down here farther. There it goes. Now it says, oh, come on now. A boat needs at least 3 meters of water to dock at the dock. Okay? So now what we're going to do is we're going to graph this function. Okay? So how to put a graph right in here? We're going to go control dock adds a page. Control dock adds a page. You might have to turn yours back on to see it. Okay? And this time we're going to add a graph. Okay? So now the function that we're going to do is the function that we just did. 1.3 sine of error. There it is. 1.3. Oops. Back to me. Come on. There we go. Pi over over 6. And then now we got to put in x minus 1. Close and close. And then plus 3.1.
I feel like you can make art.
And you can, totally. We'll get to that in second semester.
Oh, really? You
Yep.
just like put different things in?
Yep.
Because this is like the ocean.
Yep.
Can you make a fish to go in the ocean?
Okay, now we want to only be in quadrant number 1, right? So we got a lot of wasted space. So let's get into quadrant 1. So we're going to go menu, window, window settings. And I want you to make these be your window settings. So X min, we want -2. We want to go up to 24. We want to go by 2s. Our Y min, we want to go -1. We want to go up to 5. And we want to go by 1s. We want that as ours, because then that is going to match your scatter plot that you made up at the top in part A.
Yeah, no, it's not. A
Menu, window, window settings. I think it's menu 3.1. Okay? There we go. And there we go.
Okay, good.
Right? Okay? Now, it said that the dock or the boat needs 3 meters of water to dock. So how can I put a 3 meter line on here? Y equals 3, right? Y equals 3. So I'm going to hit tab. It's really easy to do. You hit tab. For me, it always just does that on the first one. And then you hit 3. Tab's right here.
It's actually right by my thumb.
It's literally the one that says tab on it.
I was actually holding it right like this. I'm like, guys, does anybody see that?
And then we got that. Right? Okay. So now we need to find what? Intersection points. How do we find intersection points?
Menu.
Menu.
Analyze.
Analyze graph.
And then you do the
Intersection.
line thing.
Okay. Yep.
But then you have to do it 4 times.
No. Just twice. Why just twice?
During the day, not night.
We're looking for the afternoon. So if you write this, what time is that one?
I did the wrong.
Approximately what? Let's say at 1 o'clock, right?
Yeah.
Right? Because it's 0.85. So that's 1 o'clock. And then the other one is going to be at what time? Which
would be
is
minus 12.7.
so like 7 o'clock? So the boat can dock between 1 and 7.
So funny.
Yeah? Now, if we would have put our scatter plot on there, it would have looked like here, and then we would have actually, it actually matches up pretty well. Okay? So, over this weekend, you've got 4 green sheets that you can be doing. You've got 1 yellow formative that if you haven't made your fixes yet, you can do that. So you've got plenty of things that you can be doing.
Can I take it right?
Okay?